Hello and welcome to SudoKanard. Here is a consecutive pair Sudoku puzzle that was created by the multiple world champion Kota Morinishi from Japan for the WPF Sudoku Grand Prix 2022 round 1. That was puzzle 10. It was worth, let me check, it was worth 40 something points. I'd say 43. And that's 41 actually, which makes it a medium difficulty puzzle. So the rule is, apart from the classic Sudoku rules, is that whenever you have one of those dots, it means that the digits here are consecutive, and that's all. And the lack of a dot has no meaning. Those two digits could be consecutive, they could be non-consecutive, and that's all. Alright, so where do we begin? Let's have a look at those. And you see that there are not that many restrictions on those because 1 and 2 leave a lot of freedom between 3 and 9. Here we have a little less freedom. And you can see that the one that is not here can't be here because it would be next to a 2, so 1 has to go here. So that's a digit, and we now know that there's a 1 somewhere here, but 1 here would put a 2 here, so 1 up there. And then, I'm not sure, this 5 is not here, could be here, could be here, with 4 and 3, and that sounds possible. Oh, this digit has a lot of restrictions. It can only be 3, 4, or 8. Let's have a look. 3 could work with 2 here and 4 there. That would work. 8 could work with 9 here and 7 there. And 4 wouldn't work because it would need a 5 on either side, and there's a 5 here. So this is either 3 or 8, and options are 2, 3, 4, and 9, 8, 7. So that's some measure of restriction. And what about this? It can't include an 8 or a 9. Because then I would need a 7. So the digits have to be between 1 and 5, and there has to be a 3. So the options are 1, 2, 3, 2, 3, 4, and 3, 4, 5. So there has to be a 3 here, and there has to be a 3 up there. So what are the options? I can't make it 1, 2, 3, but it could be 2, 3, 4. It could be 1, 2, 3 in this order. It doesn't seem so interesting, actually. Maybe that's not where I'm supposed to look. So, but let's move on with the options. So 1, 2, 3 is necessarily from bottom to top. 2, 3, 4 is from top to bottom. And 3, 4, 5 can be in either direction, which is really not interesting. Oh, that's really cluttered. That's really not that interesting. Oh, but then there is something interesting, I think, about 9 and 8. If this happens to be 9 or 8, then this would have to be 2, 3, 4, and 1, 2, 3 here. Oh, I don't think that's the intended logic. What I'm seeing here is that putting 8 or 9 here would make this 3, this 2, this 4, and then the only option would be 3, 2, 1, and there's nowhere to place a 5 in this box, which means that this would never be 8 or 9, but that's really not that useful, I think. Let's have a look at this. We see that there's a 7 somewhere here, and we can see that if there's no 7 with 3 consecutive digits, oh, and no 3, it can only be 4, 5, and 6. That's it. This can only be 4, 5, and 6, and because of this 6, it's 4, 5, 6. Indeed. Because 1 or 2 would need a 3, and 8 or 9 would need a 7, so that's the only way. And now, because of this 5 and this 5 up there, there has to be a 5 here, so there's no 2. This is a 4, and this is 3 or 5. Right. That's better. Then this here must include digits between 2 and 6. 2, 3, 4, 3, 4, 5, 4, 5, 6. So there has to be a... oh no, it could be 2, 3, 4. So it's between 2 and 6. So, but it can't include both 3 and 5. So it has to be 2, 3, 4 or 4, 5, 6. That's not so good. But there has to be a 4. So there has to be a 4 somewhere here. Oh, that cell is very restricted. It sees a 1, a 2, and those digits. So it has to be 3, 4, or 9, but 9 is impossible because it would need an 8 on both sides. 4 would need a 5 somewhere, and it could only be here, and it would be with a 3 here. And 3 would need a 2, but it would be the 2 here and the 4 there. Oh, but 4 is not available, so it has to be 5, 4, and 3. This here is not, it can only be a 2 or a 9, and though this can only be a 2 or a 9, and there's a 1 here, which removes this option and puts a 1 here. This column, oh, this 4, I have missed this, that's a 7, that's an 8, that's a 9, it pushes the 3 on top. I still need 3, 6, and 2 here, only 2 goes there. Yes, that's it, no, the argument was I need 2, 4, and 6. Okay, so that has to be a 2. Those are 4 and 6. This column needs a 1. It can only be here. That is a 2. 7 is now here. And those 2 digits are 8 and 9. Those are 2, 8, and 9. I can remove the 2. And I know by playing Sudoku that there's 1 here or there. 1 here would put a 2 here, and that's definitely possible. Well, this now is constrained by the digits here. It can only be 1, 2, 3. So 2 is in the middle, and this is a 9. With the 2 here, and 1 and 3 on. Well, both options seem possible. Now, in this box, 1 has to go here. I still need 6, 8, and 9. But you see that on this row, 6 has to be here, so this is not a 6. I need 4, 5, and 6 here. Next place to look here, something of interest is that this is 4 or 6, and you see that we can't have both 4 and 6 here, but it could still be 3, 4, 5, or 6, 7, 8, or 5, 6, 7. That's not so interesting. Oh, but there's a 3 and a 5 here. They must both be here. So this is 4. Those are 3 and 5. I get this 6, this 4. Here I need a 2. It can only go there. I need a 7. It has to be here. That's an 8. And then those consecutive digits must be here. A 6, here a 5. And that one is a 3. This is not 8. Here I need 4 and 9. There's already a 4 in this column, so that's a 4, that's a 9. This now is an 8. This 8 makes this a 9, this an 8. And there's a 3 in the middle. Those 3 digits must be consecutive. This can't be a 4 anymore, that's a 4. I need a 7 and an 8, and a 6 or a 9, the one that's missing here. But let's see here, I need 6, 9, or 5, and there's a 5 among them. Here 4 can't be in the middle. It's on either side with 5 and 6 of 3 and 2. So this is 3 or 5, and that's interesting because it's creating a 3-5 pair in this row. So that's not a 5, and this first column needs its 5 here. Those now still need a 7 or an 8, and this one is definitely a 7 or an 8. Here, I've got 2 consecutive digits, obviously, and one of them is odd, and it can't be a 1, a 3, or a 5. So there has to be a 7 or a 9 here. 9 will never go here. 9, 8, 7 is possible. 7, 6, 5 is possible. That's not what we're missing, what we're looking for. Here I need 6, 7, and 8. Sorry, 6, 7, or 8. 6, 7 here. 6 or 8 here. So what? Oh, here I need 2 consecutive digits. One of them, and I think none of them can be a 3, because it would be next to a 2 or a 4, and there's already a 4 here, 2 here. So 3 in this column must be here. So that's a 5, that's a 3. Now those are 4 and 2, this way. And that's not a 4, that's not a 4, that is a 4. Those 2 consecutive digits. I can't put a 5 here because it would need a 6 here. And then there would be no option for this. This is not a 5. So that's a 5, that's a 6, that's 8. So the options are 6, 7, and 8, but there has to be an 8 here, so those are 8 and 7. This is a 6, 8 and 7. And this now can't be a 6, so it has to be a 9. That's 8, that's 7, that's 7. This is a 2. This one now is a 6. And those 2 are, oh, this now can't be a 1, that's a 5. This is a 1, 3, 1, 3 and 5. So this is now resolved. This row lacks an 8 and a 9. This can't be a 9. That's consecutive with this 7. So now that's a 6. That's a 9. 6, 9. And the last 2 digits. All right, so the breaking was a bit tricky with what happens here. You had to notice that those two sevens restricted the positions for sevens, and I didn't pay attention to this one, I think. So being a 7 there, it limited this run of 3 consecutive digits to the option, the triplet 4, 5, and 6. So that was the main tricky part, I think. Not saying that the rest of the puzzle was just that smooth, but that was really the way in. And it was not that inconspicuous because those sevens had to be powerful somehow. Alright, so that was a very nice puzzle by Kota Morinishi, Kota Sensei. And thanks for watching this video. See you soon on SudoKanard.